Okay, so let's do a demonstration to show how these different measures of incidence, how they look. In experiment 1, it says, look at cohort 1 below, make sure you understand what the columns mean. Okay, so this is cohort 1. Let's make sure we understand what this means. In this column, in year 1, we have 0, 5, 10, up to 30 year. So that basically means we're doing measurements at these times. These are the follow-up times that we had. In the alive column, we have the number of people or individuals in our study that are still alive. At year 0, there were 1,000. At year 5, there were 833, and so on. At year 30, everybody was dead. The incidence count is listed here. It's 0 to begin with. Nobody has actually died yet. After 5 years, 167 people died. After 10 years, 334, and so on. The proportion or the incidence risk is listed here. We have at year 0, the risk is 0. At year 5, it's 16.7%. At year 10, it was 33.4%, and so on. P years represent person years. And so at year 0, we haven't followed anybody yet. We haven't collected any person years yet. But after 5 years, we've collected 5,000 person years. Okay, so we had 1,000 people in our cohort. We followed them for 5 years, and now we have 5,000 person years accumulated. Now, notice how we don't have 10,000 person years at year 10. And why is that? Well, it's because some people are no longer part of the cohort because they have unfortunately deceased. And so we are only counting those who are actually contributing to observations. So therefore we have 9,165. And this is usually the case when we're looking at survival rather than something else like risky drink or alcohol consumption, where even though you've had a transition, you could still contribute person years because you could have another transition. But if you only transition once, then you only count people who continue to actually be at risk. The rate is 3.3%, 3.6%, 4.0%, and so on as we go along. Okay, so this is the number of events divided by person years. So it's 167 divided by 5,000. Okay. Now look at the survival curve. This is a survival curve. The blue dashed line here represents survival over time in cohort 1. So between 0 and 5 years, nobody died. That's at least what our data tells us. And I'll speak a little bit about what we call censorship here, because we don't actually know what went on here. But we're going to assume that this is what it looked like. And then a few people died, and therefore this is our survival now. So it's inverted. It's 1 minus the risk here. So risk is actually 0, but we take 1 minus, so we have something that goes down like this. And then the risk is 0 in the end because nobody survived past 30 years. Okay, this is a survival curve and are quite common, and actually a very neat way of showing incidence over time. What happens if we change the number of people alive at 5 years to 700? Okay, let's change this to 700. We now see a big drop here, and then it continues down like this. So you see how the survival curve changes depending on the numbers. So, okay. Play around with that to make sure that you understand it. Just don't bring people back from the dead. So here, if you decided to go 700 here, for instance, then it looks a bit strange because suddenly survival goes up again, and that can't happen, right? So just be careful with what numbers you put in there so it makes sense. Okay. Experiment 2. Now it says check the box, show cohort 2. So let's do that. Click that. Now we have a red survival curve as well, and that's for our second cohort down here. Okay. It then says change the number alive in cohort 2 at 5 years to 700. Okay. At 5 to 700 here. And at 10 years to 550. Okay. Now it asks, what is the proportion, that is the risk, at 15 years in both cohorts? Okay, let's look at that. 15 years here, the risk is 50%. So the 15-year risk of survival, or really of death, is 50% in cohort 1. In cohort 2, it's the same. But which cohort would you prefer to belong to? After 15 years, the risk of death is the same, but which one do you prefer to belong to if you had a choice? Well, I don't know what I don't know about I don't know about you, but I guess I'll pick blue then. Cohort 1. It looks like you have a big drop off after 5 years in the red cohort, and then it sort of the risk of death slows down a bit. While in the blue cohort, you seem to live a little bit longer here, but after the 15 years, the risk is the same. But it still looks like this risk here, you have a little bit less risk in these years here. So I'd prefer the blue one if I could choose. Okay, so what does that really tell us? The proportion says that the 15-year risk is the same in both cohorts, but individuals are going to probably have preferences over these two, but the risk doesn't really convey that. But the incidence rate does. Look at the incidence rate. At 15 years in the blue cohort, the incidence rate is 4%, while the incidence rate in the red cohort is 4.4%. So you have more events per person years, more events per person year observed than here. Okay? And so you'd probably have a strong preference for cohort 1. Okay. Now it says, change the number alive in cohort 1 at 20 years to 200. Okay. Change the number alive in cohort 1 at 25 years to 50. Which cohort do you now prefer? So the incidence rate in both these groups at 30 is the same. But I don't know. Which one do you prefer? You can have a lower risk in the first half of this study. You could sort of have a lower risk of mortality here, or you could have a lower risk in the second part. And preference here, it's up to you. Have a think about which cohort you'd prefer.